Venus, the second planet from the Sun, has long fascinated scientists with its thick clouds, crushing pressure, and extreme surface temperatures. Often referred to as Earth's twin due to its similar size and mass, Venus is anything but hospitable. Its atmosphere is a suffocating mix of carbon dioxide and sulfuric acid, with surface temperatures hot enough to melt lead. Yet even in this inferno, NASA has just detected something unexpected, an unexplained heat wave sweeping across the Venusian atmosphere. The discovery was made using data from NASA's Parker Solar Probe and Earth-based observatories. Scientists were monitoring Venus' upper atmosphere during a recent flyby when they noticed a sudden spike in temperature. This localized heat surge, unlike the planet's already scorching baseline, appeared to rise rapidly and cover a vast area. The source of the heat wave remains a mystery. Unlike Earth, Venus does not have strong seasonal variations or known volcanic activity that could explain such fluctuations. Some researchers initially suspected solar activity, such as a coronal mass ejection, might have heated the atmosphere. But solar data from the same period shows no significant solar storms. The temperature anomaly was detected in the mesosphere, about 100 kilometers above the surface. This region is typically cooler than the lower atmosphere, making the heat spike even more surprising. Infrared measurements revealed temperatures soaring hundreds of degrees above normal. The heat wave lasted for several Earth days before dissipating. No visible signs of atmospheric disruption or chemical change accompanied it. This suggests the phenomenon was energetic but not explosive or reactive in nature. One theory proposes that Venus may have dynamic atmospheric waves similar to jet streams. These waves, driven by unknown internal or external forces, might occasionally concentrate heat in localized regions. Another possibility involves gravitational interactions with the Sun or even Earth. Tidal forces could be triggering hidden instabilities in Venus' dense atmosphere. Magnetospheric anomalies might also play a role. Though Venus lacks a global magnetic field, it does interact with the solar wind. Some scientists believe temporary magnetic fluxes could create energetic hotspots. However, without real-time magnetic data, this remains speculative. Researchers are also exploring whether the heat wave is tied to a deeper process inside the planet. Venus has been geologically quiet in recent observations, but that could change. A massive subsurface gas release or tectonic shift might send thermal waves upward. If so, the heat wave might be the atmospheric echo of internal planetary activity. Another fringe hypothesis considers the presence of high-altitude chemical reactions. Certain compounds in Venus' atmosphere might react under specific pressures and sunlight angles. This could result in sudden energy releases akin to heat pulses. Still, no conclusive evidence for such reactions has been found. NASA scientists are now combing through data from multiple missions, including the Venus Express and Akatsuki probes. They aim to cross-reference previous temperature anomalies to identify patterns. If similar heat events have occurred unnoticed, it could indicate a recurring planetary process. This discovery adds to the growing list of mysteries surrounding Venus. From unexplained UV absorbers to signs of potential phosphine gas, the planet defies simple classification. It is both a hellscape and a scientific treasure trove. Understanding Venus' atmosphere could also shed light on Earth's own climate future. The runaway greenhouse effect on Venus offers a cautionary tale of atmospheric imbalance. If heat waves occur there without solar input, it may suggest feedback mechanisms we don't fully understand. This could inform models of climate change and planetary habitability. NASA and other space agencies are planning new missions to Venus. Veritas, Da Vinci Plus, and ESA's Envision are designed to map the surface and analyze the atmosphere. These missions could provide more detailed observations of future heat events. Robust thermal imaging and atmospheric sensors will be key. Scientists are now considering how to design instruments capable of detecting transient heat waves. Improved data resolution and frequency are needed to capture such fleeting phenomena. If this heat wave is a one-time event, it challenges existing models. If it's recurring, it suggests a hidden planetary rhythm we've yet to discover. Either way, Venus has once again reminded us how little we truly know about our celestial neighbors. The heat wave, unexplained and extraordinary, is a signal, an invitation to look deeper. It reminds us that even the most hostile planets are alive with motion and mystery. And that science, at its best, begins where certainty ends.